Yes, regarding Lab 1, so let us go through what you need to implement. Basically, uh, the lab will be counted as pass when you implement all the operators, so, obviously. Uh, so you also implement the evaluation part and the test passes. So the test should be passed. As well as querying the database. So basically, you need to demonstrate these queries, so they need to be executed. And and why am I saying this? Because and obviously, so the Wumpus world should work based on reasoning. So the lab will be passed when Wumpus is functioning based on reasoning. So insertion in the knowledge base and the decision supported by evaluation of knowledge. Because it won't be passed. You can do it in some other ways, so that you kind of implicitly uh, or you implement some shortcuts, or not based on logic. So in this case, we will have troubles accepting this. So any questions?
What sort of shortcuts would that be?
I mean, well, like programming in so hard coding certain agents. Yeah, so that this kind of, so no hard coding, so it should be I mean so all decisions of the agent should be based on evaluation and insertion in the knowledge base.
Proper solution would be using resolution, I think. Okay. That seems to be a lot of work, but okay.
Yeah, I mean, this is the most time-consuming lab, but
Yeah.
it's the other one is simpler somewhat. Okay, so let's switch to today's topic, and I need to do some adjustments because somehow some demonstrations not functioning. But I see if I can fix it by tomorrow. So the what is left on the menu, so to say, in this course. So today we will be talking about semantic query language. Yes, I will do it today. So I'm sorry, the last week was a bit crazy. Certainly I will do it together with this one. Um, right. So today we will be talking about semantic query language, which is Sparkle. Why do we need it and such? And tomorrow we will be talking about reasoning. So what kind of reasoning is implemented and logic. So the relation to logic of what we have learned in the second part of the course with RDF ontologies. And also we'll look at creation of rules, so and discuss future developments and how you can use this information in the context of AI or machine learning. Today I will do some very simplistic demonstration of it. Yes. Last week, so we started to talk about ontologies as explicit specification of knowledge to be shared between different actors. And this is important that we need to agree on the format of description of objects and concepts so that this knowledge becomes interoperable. And so we need a special language for that, obviously. So that's why we talk about formal specification of shared conceptualization. And so the information flow was that we started this module with formal language for describing resources and subject predicate object format, so resource description framework language. And then so last time we saw that it's very limited to this kind of notation. So if you want to describe a more complex relationship between belongingness of certain instances to classes, and you want to have more complex structure or relationship between classes and between properties and such, then this syntax is not enough. So you need to make a more flexible and rich language. And we consider two languages. So basically the transition from RDF to RDFS, so RDF schema, and later on to its generalization in the form of OL, so web ontology language. And RDFS and OL, so it still it contains syntactically, it contains same RDF statements, so triples, but these triples are now applicable to general concepts and relationship between concepts and their properties. So in fact, OL is not a single monolithic or solid language. It's a family of languages with different flavors or customizations, basically, to address specific needs, specific use cases. So tomorrow we will be looking into reasoning. So some types of applications require, for example, or are better conceptualized using rules. So if-then rules, then you don't need the whole of semantics of the full capabilities of all. So there is a subset of it, or it's called profiles, that is just optimized for that use cases. For those use cases, and there are other profiles, as we will talk about tomorrow. And so on top of the language itself, so it offers this description logic, so the which provides the means of reasoning on data presented in this way. So, and again, just about reasoning, we will talk. So this is the topic of the last class. So today we will focus on something different. So we start with having a closer look at how ontology is created, and in Protege. And for these, I want to bring 2 points here. I have this my website where I published all the ontologies that I refer here. You can download and directly to Protege and study it. I derived, well, I modified from some existing ontologies that I got from my colleagues, just to, and then I basically modified to for own use cases. So right now we will have a look at the ontology in this file, cars. And again, the reason for choosing this is, let me see, it's just to demonstrate the process of creating an ontology in a kind of reverse engineering way. So we let me first file open from URL, and you specify the URL here and load it. So somehow, just this morning, this query part stopped functioning, so I need to debug it some other. So what do we have here? So we have entities. And I want directly, I want to navigate to person, employee, this one, so the one that I have inserted. And now I want to put it side by side with this story that I want to describe. So this is the knowledge I want to represent. So an individual named Alex Chapin, who is a friend of mine, and he works at Ericsson since January 2017. So I want to insert this record into a knowledge base. Or I have already inserted it. So, and I just want to kind of backtrack the steps again in a partial way, so that you can see that. I mean, if you would start from this story as a starting point, so it would require quite some work on defining the classes and concepts and properties around it, so to make it right. So what do we have here? We have a company. So we have a type. Well, we have a person, first of all. And this person, he also is an employee. So it's a class of it's a class of activities of this person. And we have a company, and the company has and it means that as an employee, so he need to have certain attributes. I mean, where he works, the time of employment, and at the same time, so the company should also have some inverse property, so that that there are employees inside, and so now we will see how it is implemented. So we start with this. I don't know if you see it, but you see it somehow. Yeah. We start from to look from classes. And well, here it's, this ontology contains different stuff. So for us, it's important that we focus on class person and different subclasses, so occupation. So persons with different qualities, so to say. And you obviously can define it as you please. So as an employee, so you see it. So it's a subclass of person, and also somebody who has a job record. So So the job record is applied to this person, basically. So you need to define the relationship. So if I can go back one slide or a couple of slides here. So you need to define the hierarchies of properties and the relationship to the classes. Yes, and so we go back and as an employee, so it has a property applicable to it, which has job record. So again, as if we it's a sub property of has record, and also has an inverse property. So that allows this kind of bidirectional reasoning. Who has a job at this organization, or vice versa, at which organization works a certain person. And then if you go to a specific record, then so this record is this is instantiation of a job record, which has different properties in it, and one of them is Ericsson again. So now I want to show the validity stuff. I think it's job record 3. Yes, and one of the properties, the validity interval of this record. So somewhere here you instantiate that it's I mean the time of starting the job. So again, in this very quick and ad hoc navigation, so my message is that it is quite sophisticated to create ontological descriptions and create them correctly, and that is one of the challenges, as we will talk tomorrow, that hopefully, I mean, could be overcome with even with the help of large language models, who actually can make them consistent. So one of the typical problems is inconsistent description, so that resolution of queries fail at some point. So yes, but if you made it right, then you have a knowledge base. So basically, it's a database, but not of kind of it's a database of kind of non-uniform data. So so the data is kind of exists somewhere in your knowledge base, and you want to interact with it. And using properties, you can do inferences, as we will see tomorrow. So there are existing knowledge bases which are written using RDF-O framework, and they can be used for different purposes. So one of such databases I mentioned last time already. So it's a DBpedia or a Wikipedia. So it's a formal description of information presented in the Wikipedia. So another type of of database of this kind is oops. Is Data Commons, which well contains knowledge bases on different domains. Yeah, so that you can use. So, but as we have this storage of formally described knowledge, so we need to have means to interact with it. So we need a special language, which is which allows navigation through all this data. And so such language is semantic query language, which is acronymized as SPARQL. And it allows to interact with RDF represented knowledge. So more formally, you can retrieve values from structured or semi-structured data. You and you can also do transformations of RDF data from one vocabulary to another. What do I mean by this? So you can, so the result of the query, as you as you will see, so you can output to your own customized ontology. So you pull the data and you can construct your own data set. So this is the these are the sources of information, and so most of the stuff you can find on Google and even ChatGPT nowadays. But I would stick to Google unofficial description of API available on the network. Key features. So in general, a SPARQL query consists of select statement and condition statement where and some filter clauses. So in addition to select, so that's what I mentioned before. So you can use construct. So in this case, you you create your a new knowledge base in a different format. And then you can have other options like find all statements in the database that provide information about certain resources. So it's in general the SPARQL query looks like this. So you define prefixes for ontologies which you are using. So the type of query comes here. So you select something from the database and specify the condition. So here you specify the conditions. So basically here you have many RDF triple patterns. I will show you later on an RDF query which is supposed to retrieve data that I previously created in my ontology. So you for that you basically need to know the structure of your domain, so of concepts and properties. So it's not that I mean, you need to have attitude of working with knowledge bases pretty much same as with databases. So you need to know this the format of the knowledge. Huh?
How data is stored. How the data is stored.
Yeah. So you need to know the data model basically, So this is a very simple query. What does it do here? So we have a prefix for well, it's a friend of friend ontology. So there are standardly defined several of them ontologies for basic concepts that you can use for definition of again fundamental concept like person names, etc. So you don't need to redefine them all. So this kind of skeleton ontologies exist, and one of them is this one. So let's see if it's retrievable at all. So it's a dictionary to be used in different contexts of semantic web. So not to redefine it. So you basically in all cases. So you should rely on the standard dictionaries / ontologies. So what do we have here? So select name and age of people, and here we have RDF statements to match. So so the question mark indicates it's a variable, basically a user-defined variable. So it's some person well is a so take all records belonging to a class of person. So also who has record name and age, and then you supply also filter, so a condition which to filter out the records. Looking a little bit ahead, working with large knowledge bases, so you need to be aware that there can be you don't know in advance how many records are there, and there can be very many, like in order of tens of thousands, for example, hundreds of thousands. So and so there is another important statement, so you will see later on. So you can write limit, so the number of records SPARQL resolver will return to you. Then, as this is a kind of semi-structured data, so there could be records with some missing parts of information. So some people may have a record, for example, of having a pet, some not, and you can handle these cases that you can include these cases in the optional clause. And in addition to this, so SPARQL offers some basic processing features like counting records, computing sums or averages. But in many cases, well, not in many cases, practically a useful case is to retrieve a portion of a knowledge base so that you can use for your own processing. So that's what I want to demonstrate. Hopefully, I will demonstrate today. I mean, on a very simplistic machine learning example. So you can also, I mean, again, so you shouldn't remember all of these. I mean, you can find it if ever needed. So all this kind of optimization of queries will come naturally, but you can, in one statement, you can include multiple relationships. For example, if you want to find if friends of somebody, so then you can chain these properties in a single statement. There are several. Exactly. So you need to have a resolver to run this queries, and there are several available Sparkle endpoints. Today I will mainly use this one, and as I said, so I need to still do some debugging why my typical queries didn't run this morning. Right, that I will use for demonstration today. So, but already now I can just control it. So this is the Sparkle endpoint for DBpedia. So it's a front end for the whole DBpedia knowledge base. So you write your query. So you will we will have some running examples later on, and then it will return you a file with the results. So, but the important point is that you need to know your data model. So how your data is structured to construct the queries. And well, this is part of the engineering procedure, basically. Let me see some more interesting stuff. Yeah, maybe instead of just me parsing this simplistic example, so I can ask you to give me an idea what this query can be all about. So looking at this portion, you can get an idea of what of the data model, basically.
Yeah, with a name as a variable, it pulls out like a personal info, basically, and you have some option to add age.
No, okay. So it is like this. So here in the where part, this is something that exists in the knowledge base. It means that there are records about different persons having first name and name as an entry. Some of them have also they also have age information. Not all of them, only some of them. And this optional statement tells that you need to take both the entries without age and with age. So so it looks like all the records they have a name in it. But you also want to
Fetch the age also.
exactly. So because you say you want to return it. So for those, I mean, it won't return anything if you don't have it. So then this query probably won't run because these guys don't have age in them.
Database.
Yeah. So if you
So what, doesn't it run at all?
huh?
Doesn't it run at all?
Uh,
The age missing. I was
no,
assuming,
it won't because
I was assuming it would be like a default value,
yeah.
maybe a 0. I say,
Mm, I'm trying to figure out what it will give you if you don't specify age. Maybe it will. If I remember correctly, it will omit those records without the field. So here it will include both types, kinds of records. Another example. So now I want to ask that you use Google to parse this stuff. So I will make it zoom in a little bit. So this is the person. So we have some things which I think is kind of interesting that you find out. So this VDT, I just can give you a hint. So VDT stands for Wikidata. Wikidata type and Wikidata. So can you Google? So I mean, what these things are. So VDT P31, VDQ5. Again, so this is an example of this shared nature. So you rely on already existing ontological descriptions and dictionaries, which are created for compatibility and for shareability purposes. So let me do it also in parallel.
at the birth date.
Uh-huh. Instance of VG equal 5. What is that? That should be person. Human. So person, instance of human. date of birth. So here we have an tree notation, as you see. So person, date of birth is date of birth, and then you specify time interval basically. And then here again, we didn't talk about it, but so if you ever come across constructing Sparkle queries, so here you can specify commands to the resolver. So what kind of service to so that's for example search to English language database. So it will then select all people with the date of birth and a person label, so which is apparently part of the story, part of the data model, which are born between 1st of January 2015 and 1st of January 2016.
Is that based on persons from Wikipedia? From the Wikibase?
No, not here. It's not specified.
Okay.
So you can you see. So this is an incomplete example. So that's a good question. So here it's missing the prefix part. In the prefix part, you would specify where to. You will specify the path to the Wikidata. So where, but this path will be used purely to retrieve this encoded instances, so as a dictionary. Then, in addition to this, you need to specify the from which ontology you should take it. So it can be customly created ontology, but it should create this should contain this fields. Okay, so let me just skip some stuff and see what we have here. Return to it tomorrow. So we go to DBPDM. So now we see a couple of interaction with them with it. And here I want to retrieve the birthplace of William Shakespeare. So, and I don't have. I guess I don't have it. So let me just select distinct place. Where let me just do some shortcut. Um, where so let me see. If not, we go to another example. Um, chun, 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 chun. So let's see. We need to create prefixes also. Prefix DB. DBO. That's not DPC. Ontology. So let's see. Hopefully it will work. Execute query. No way. It was not my day for demonstration. Then I will continue with the next demonstration, and that I will return tomorrow. The next should work for sure. Yeah, so let me first run it just to be sure that it actually, and then we go through it. At least I have the recorded answer as a file. Yeah. I want it in CSV format. CSV format. Let's see. Okay. Yeah, well, at least it returns something to me. Thanks God. What do we have here? So let us have a look at this, and we will use it until the end of the class. So we use so you see this DBpedia has different parts. So one for ontological description, another description of properties, and what do we what do we look for here? So we look for so our output should contain person. So let me set it side by side. So person, year of birth, lifespan of parent one, lifespan of parent two, and lifespan of a person. Yeah, and actually, if you do this kind of generic query, so it has plenty of people satisfying this condition. So it starts quite early in time. So it will show you records for historic people. Here, different kings and queens and such. But what do we have? So we search for these records, like person of type person, with the birth date, death date. It should have field parent, so it will be filled in parent one, and then you for this parent, so you search for its death date and such, so you can parse it. I will upload right after the class to me. and then you do some obvious filtering. So let's say maybe there are some repeating records you don't know, and here you do these calculations inside the query. So the Sparkle resolver will do some job for you to calculate the lifespan. Yes, and then you also instruct what to do with it. I mean, so with respect to sorting. So that was the result of the query. And again, so what? So what can you do with it? You can think of creating your own machine learning model, for example, with this. So and again, creating machine learning in this context, so even if whether you had a previous course or experience or not, so you can in this very simple example, you can use our dear Google services for that. So so let me see if I have this example here. See the one of these things I tried last week. Yeah. No, that's not the one. Not the one. Let's try doing them from scratch. Google Sheets. And let me see if I have it downloaded somewhere. Mhm. But what we do here is file, import, and upload, and let me see if I can just drop it. Simple data. So here we go, and so let me just have my so what we want, what we can do, we can create a regression model with this, and so we go for extensions, and so we can use this plugin, which is called Excel Miner, for example. So I don't know if you used it or not previously. So it's quite good for different basic machine learning and statistics tasks. And here we are interested in regression. And what we will do, we will build a model for predicting the lifespan of a person based on its year of birth and lifespan of both of the parents. So and again, so the output, the Y, will be the lifespan of a person. So and so for this we just need to select. So yes. Now for input range, we take basically all these three variables. Yeah. That will be our input range. Let's see. Now, that's something. So we do. So the intervals are okay. Output range. Output range is yes, that's definitely will be this one. Let's see. Yeah, okay. So now something is happening. Yeah, so this will be the coefficients of the model. So again, let me put it side by side. So it's a you construct it like live predicted, and here will be the equation. So it equals the intercept, so the free parameter plus first variable multiplied by okay, so before that I need to, yes, it will be here. So, let me do like this. What was year of birth? Year of birth. So that's what you enter as your parameter. So for example, let it be my age. Then so we take the second variable was lifespan part one. Well, let's put my mother instead because my parent she's still alive. So 1949. Lifespan of parent one, I think was 81, and lifespan of parent two, it was, I think it also was around 52. So and here we say so we take this coefficients and multiply them with the respective input. So first coefficient was for year, second coefficient plus coefficient multiplied by lifespan of parent 1 plus third coefficient multiply by lifespan of parent 0. So, and so it is. A linear model, so free coefficient and coefficients in front of each variable. So what did we do here in this simple exercise? So we build this model again based on the data that is available as part of knowledge base. So this knowledge base is not created for that purpose, obviously. So it just so if you look at any of the entries here, so that's just records about some historical people or famous people, whoever existed on the Wikipedia, and we just use it for purposes of creating a simple learning model. And I think we will end for today. So tomorrow I will do some recap and we continue with the reasoning. Okay, thank you.